Hi, in this video, I will be talking to you about a project that I recently did in Neo4j. That is a graph database where I created a custom data set and used it to explore social connections between me and my friends. So without further ado, let's get started. So this is Neo4j Desktop, and I will walk you through how to set up a project and get started. So we create a project, and we need to add a local DBMS. You can name it whatever you like. I think we'll just stick to the defaults for now. And you need to set a password so that you can access it securely later on. And then we will go ahead and create that. So the graph database management system usually takes a couple of seconds to instantiate. And so we will let it do its thing. So the graph database management system has now been created, and we will go ahead and start it. So again, that will take a couple more seconds to instantiate. But then once it does, we will be able to open an instance of Neo4j browser, which will provide us the interface to be able to enter queries and create nodes and relationships and all of that, which I will be walking you through. So just gonna let it get started. So the database has now been started and instantiated, and we see that there are two databases here. There is a system database and there's a Neo4j default database. The system database is grayed out, which means we cannot access it, but we do have access to this Neo4j default database. So now if we press open here at the top, that will open up an instance of Neo4j browser. So this is our interface where we can type in Cypher queries and be able to create a network which will have nodes and edges, which are the relationships between the nodes. And then we will do all kinds of exciting queries with that data set. So before we jump into that, I will walk you through our data model for this project. So I am now on a website called arrows.app, and this is a data modeling, I guess, online application tool that helps you in thinking about how you want to proceed with making your nodes and what relationships connect them. So it's a really good data planning and data prototyping tool so that you can create your data and relationships properly. So in the center here, we have a node entity of person, and we see that it has a person entity or node has different relationships with other nodes. There are movie nodes, book nodes, class nodes, and university nodes. So the relationship between person and movie is that a person has watched a movie, a person has read a book, a class has a textbook of that is a book. A person has taken a class. A class is a class of university. A person goes to university. And this is a self relationship, but a person node can be friends, is friends with another person node. So that links two person nodes together. So this is the data model that we will be basing our data on. And I will walk you through the Cypher queries that I wrote to be able to create our own custom network. So here are some queries, well, not queries. Here is the data, Cypher queries to create the data nodes and relationships that I have already written, but I will walk you through what all of this maybe gibberish means. So first, we need to actually create instances of the nodes that we just described. So we start by, and this is all the Cypher query language, which is what Neo4j uses in order to map the relationships between nodes and edges. So we start by creating and then open brackets. And then we see there is this letter A : person. So the letter or the word, as you can see down here, in front of the colon is an alias for that one specific instance of a node. That node that we're creating here is of type person, which is the orange node in the data model that I had just previously showed. And then this instance of the node has specific properties called name, age, and state. So in this case, the instance of person with alias A has a name Ayushi, that's me, has an age 23, and has a state Virginia. This other instance of person has an alias K, and we see that this person's name is Kelsey, her age is 26, and her state is Massachusetts. So we go on and create some more instances of different node types that I had just described in the data model. So we have aliases, book 1, book 2, book 3, so on, that are instances of book. And then they have properties called title, author, and year. So that is the title of the book, Mathematics for Machine Learning, for example, the author, Mark Desenroth, and the year that it was published. So we do this for a couple of other books, and we can see that there is an interesting selection. There are some academic texts. There is, a book on data feminism, and then there are some Harry Potter books. Interesting. That will create some interesting relationships that we will see later on. We proceed by creating some more instances of the movie node. Again, there are aliases, movie 1, movie 2, 3, so on and so forth. And again, the nodes of this type have some properties: title of the movie, the director, and the year that it was released. The other node was university, and so we go ahead and create the node university with a name and what state it's based in. We do the same for class nodes. They have aliases and the name of the course or the class. So these are all the nodes and their instances which we have created, with each have some properties. That's great. Now we need to map these nodes to each other. In other words, we need to form connections or relationships between these nodes. So we can do that in Cypher, and honestly, it's pretty simple. So again, we have the same, very similar syntax where we use the word create, and then we have this alias. Remember how we had the alias in front of the specific instance of the node? So we are mapping instances, very specific instances, to each other and defining a relationship. So for example, CS661, that is of type class called Python programming, we see that, we connect it to university, Pace University up here, using the relationship called isClassOf, as we had described in our data model. So we go and do that for all of the class nodes that we have created. So 661, 623, 660, so on and so forth. And we map them all to university using the relationship isClassOf. We do the same now for our person instances and the classes. So A was an alias for Ayushi, me again. And we are mapping Ayushi to the classes using the relationship has taken. We do the same for the alias K, which is Kelsey, my friend. And again, we are mapping the courses that Kelsey has done using the relationship has taken. We now map some of the classes to book entities using the relationship has textbook. So a class has a textbook, book name. And we define self relationships now. So this person instance is friends with this person instance and vice versa. So Ayushi is friends with Kelsey and Kelsey is friends with Ayushi. We continue creating some more relationships. So person is being mapped to university using the relationship goes to. And interestingly, you'll see here that we are defining some properties for the actual relationship itself. So we know that the nodes, that's A and university, they have their own properties. So if we go back and look at the properties of A up here, so A has properties of name, age, and state, and university has properties of name and state. Well, as it turns out, in Neo4j, we have the option to also assign some properties to the actual relationship. In this case, we are setting properties of degree, so that's MS in data science, when the start, so that's May 2022, and graduation, which is December 2023. We go ahead and continue mapping out some relationships between person instances and book instances using the relationship has read. We do that for person and movie instances using the relationship has watched. And finally, last but not least, we map movie instances and book instances using the relationship is based on. So a movie is based on a book. This is really good and really exciting. And now we will actually put this, copy paste in this case because it's already written, and put it into our database. So let's go ahead and do that. So I am back now in Neo4j browser, and we see here up here is the console, and we can go ahead and paste all of the relationships and all of the nodes, node instances that we had created, and just press enter. Wow. So we get a confirmation message from Neo4j saying that it has added 24 labels, created 24 nodes, set 59 properties, and created 46 relationships. Exciting. We will now check this. So while we did get a confirmation message from Neo4j saying that it has created our network, we want to actually check this. So in Cypher, we can type in match all, return all. And when we execute this, we see that it has created a lovely network. And it is also color coordinated, very similar to the data model that I had showed, which is great. And we see here on the right side is that the nodes, they're color coded, and it's telling you that an orange node is a person, is of type person, a green one is of type book, pink of type movie, so on and so forth. And it's telling you how many exact instances of that type of node exist in this network as is right now. And if we hover over any one of the nodes, we see that it gives you more information about the specific properties. So right now we're hovered over Harry Potter and the, doesn't say, but, oh, Harry Potter and the Chamber of Secrets, that's right. And we see that it has an author of J.K. Rowling, and it was released in year 1998. That's great. And we see that it is connected to some other nodes. So it is connected to Ayushi, using the relationship has read because Ayushi has read Harry Potter. It is also connected to this pink node movie, using the relationship is based on. So Harry Potter and the Chamber of Secrets movie is based on Harry Potter and the Chamber of Secrets, the book. So this is really interesting that we have a whole network. Now we can go ahead and explore this in more detail. So as an example, let's look at all of the people who have read books, and we will also obtain the relationships that they have between them. So the Cypher query language says that you should, your query should say match, and then the type of the node, and then you put in the relationship that you're looking for and map it to the other node. And then finally, you return the person nodes, the relationships between them, and also the book nodes. So we execute that, and we see here that it has returned a smaller subset of the network that we saw below. So in this case, we see that our person nodes, which are Kelsey and Ayushi, are have relationships with different instances of book nodes. So Kelsey has read a book on data feminism. Ayushi has read 2 books on Harry Potter. I've actually read all of them, but for simplicity, didn't add all of them. Kelsey and Ayushi have both read this book, Artificial Intelligence, and Ayushi has read Mathematics for Machine Learning. Oh, but what's this? We also see that there is a relationship between Kelsey and Ayushi, and it is bidirectional and is friends with. So Ayushi is friends with Kelsey, and Kelsey is friends with Ayushi. And again, on the right-hand side, we see that there are properties that pop up when you hover over a node. So Ayushi has properties of age, name, and state. Kelsey has similar properties, and then the books have, the properties that we defined earlier. So let's look at some more queries. So how about we look at all of the classes that the person entities have taken? So we do that by matching person to class using the relationship has taken, and then we return the person name. So here we're actually referring to one specific attribute or property of that node, which is the name, and a collection, which is very interesting, as we'll see, of the class name. So again, that is referring to one specific property of the class, and we're calling that class is taken. So let's see what that looks like. We execute that, and oh, it's given us a table. So as said before, we aliased p.name as person with a capital P, and that is exactly what we see here. And we had aliased this mysterious collect as classes taken, and that is exactly what shows up. So we see that a person instance of Kelsey has a list or collection, if you will, of different classes that she has taken. So Python programming, database management systems, so on and so forth. So these are all of the classes that Kelsey has taken. Similarly, we have the instance of Ayushi and all of the classes that she has taken. So this is great. Now, if we look at all of the books and all of the movies that a person instance has read or watched, we will obtain a count of that this time. So this time we are mapping a person node using the relationships has read a book or has watched a movie to movie, and we are returning the person name, again referring to that one specific property, and also the total count of movies that they've watched or books that they've read. So let's execute this, and we see that Ayushi, the instance of person called Ayushi, has read 10 books. Actually, I think that's books and movies combined. And the Kelsey instance of person has read or watched 3 books and movies. Now, what if we wanted to look for certain books or movies that were released after or before specific years? So now what we're going to do is match book instances and match movie instances, and then we're going to put a condition on all of the matches that Neo4j would have returned. So we're going to constrain book instances using the property of year, and we say that the year has to be strictly greater than 2010, and or we're going to constrain movies again by the property year and say that we want movies returned to us that were released in or after 2020. And we return both of those and see what we get. Great, so this has returned to us all of the books and all of the movies that fit that constraint that we set. So if we hover over the properties, we see that the books and movies have been returned to us that fit that constraint. So this is really good. Now let's dive deeper into those relationships. So we're going to look at classes that the person instance Ayushi has taken, but not the person instance of Kelsey that she's taken. So we write this query matching person with a specific name, with specific relationship to another node. And now we say we're putting the condition of not exists. So we match the same thing for Kelsey, but this time this is going to return all of the classes that Ayushi has taken that Kelsey has not. And we see that Ayushi has taken artificial intelligence, the class, which Kelsey has not taken. Now we can also look at classes that students have taken together using this query. So we are matching person nodes to other person nodes using the relationship friends, and matching person to class using the relationship has taken. So we see actually that this query is bidirectional, and we see the results like so. So we see that person 1 and person 2, we know that they have a relationship is friends with because we defined that earlier. And we see that the common classes that they have are these. And because this is because we only put 2 instances of person in this graph, and they happen to have the same node instances, it is actually the same list of classes. But if we had put in more data, we probably would have seen a little more variety. But that's okay. So how about the university node? Kind of forgot about that. All right, well, let's figure out which person instances go to the university. So again, we're going to return the university name, the university state, and the count of students that go to that university in this data set. And we see that there is one instance of university called Pace University that is based in the state New York, and there are 2 students in this data set enrolled there. So what if we wanted to look at some regex matching? So that is regular expression. Well, we can actually do that. So we can find all of the movie titles where the movie title contains Harry. And then we're going to get the titles of those movies back. We execute that and we see that there are 2 instances of movie that have, Harry in the title. So that's Harry Potter and the Sorcerer's Stone and Harry Potter and the Chamber of Secrets. We can also see all of the books, the book instances that have been used as textbooks. So we do that by matching class instances to book instances using the relationship has textbook, and we get the count of each of those, and as well as the title. So we execute that and we see that there is a book, Mathematics for Machine Learning, and there is one class which has used that as a textbook. Similarly, there is one book called Artificial Intelligence, and there is one class in the dataset that has used it as a textbook. Finally, we can look for all of the people who have watched a movie that is based on a book that they've also read. And we execute this, and we see that there is one instance of person called Ayushi who has read Harry Potter and also seen the movie Harry Potter that is based on that book, and same for the other Harry Potter set. So that is a really quick overview of the project that I did using Neo4j, using this graph database to kind of explore the connections that we have with each other. And it was quite an interesting project in terms of creating the relationships between each other and creating custom nodes. And of course, it is a data set that you can always go back to and expand, and it can also be done very easily in Neo4j. So thank you for watching, and I hope you enjoyed.